Hello everyone. Yeah, hi. So
Hi, Arun.
today, yeah, hi. So today we're in week 4. So last week I was not available. I was not well actually. So Afnan, I think he has discussed few things. So anyhow, Afnan also will join today. So anyhow, like week 4, any kind of doubt or any issues I need to discuss?
On the week 4, sir.
Yeah,
The week 4, the last part of week 4, if you can discuss the basis path and the DD path, it's not clear
yeah.
at all.
Okay. Yeah, yeah, Bhavya, you can also say like what is your question? Maybe I'll take it together. Bhavya, Bhavya, do you have any question? Basis path testing. Okay. Yeah.
Yes, a basis part testing and question 5 of the practice assignment.
Okay. Okay. So this is it's visible, right?
Yes, sir.
Yes, sir.
It's
Okay.
visible.
Okay. So basically the doubt is there in this part and this part, right? Okay. Mm, okay. So there are three things here. One is basis path testing. Second is what is independent path or linearly independent path. And third is what is cyclomatic complexity, right? So the basis path testing basically try to test the linearly independent paths in a CFG, right? The linearly independent paths also sometimes referred as basis paths, right? So what we need to check out in a program. So whenever we try to find out some test path in our CFG, not program. So I have a program. From there, I have drawn the CFG. Now I have to find out the linearly independent path. So what are linearly independent path? So each linearly independent path must have at least one edge which is new other than other linearly independent path. Right. So linearly independent path starts from the starting vertex, it ends at the end vertex, right? So now the point is like, how do I know like how many linearly independent path could be there in my program, right? It could be many. So that's why we use this cyclomatic complexity. So this gives the number of linearly independent path could be there in our program. So uh, the basis path testing algorithm is written in a way we start from the starting vertex, try to reach the end vertex through a path, right? Now, each time I traverse through a path, um, I try to find out, is it a new path? Is it a new path in the sense, what are the existing path I have already? Am I adding a new edge into it, right? So if I find every time a new path, then each will be considered as a linearly independent path, but maximum how many linearly independent paths I can have, that will be given by my cyclomatic complexity, right? So you can say this linearly independent paths are my test requirement for basis path testing, right? From there I'll derive the test cases for the basis path testing. So if I want to do that, I'll take a sample. Let me see if there is any graph here. Yeah, so let us see, this is a simple graph, right? So see, what is the cyclomatic complexity of this? So it could be defined in two way. So one is, I don't know which formula is given here. It's given age minus number of nodes. So uh, age minus number of node plus 2, right? Or you can say number of decision nodes or number of decisions statement or branching statement plus 1. So it could be calculated in both the ways, but this is both this is much basic formula. If you just check out, um, the number of nodes over here is 6, and if you look at the ages 1, so I won't take this age, okay, 1 2 3 4 5 6, right? So it's a 6 minus 6 plus 2, so it's 2. Even if you go by this formula, then the number of decision making happening here 1, 1 plus 1 2. So now what the cyclomatic complexity says, a number of independent path I can have. So now see, as per the algorithm, suppose I have to go from 1 and I have to reach 6. Suppose I go by this way, right? So this is a new path, definitely. Now, do I have more paths to reach from the starting node to end node? So I can go by this way. So I can basically find two independent paths. So let me put two independent paths. So it is 1 2 3 4 6. Another is 1 2 5 6. So these two are my test requirement. So I need to create the test cases in a way so that I can cover these two paths, right? So this is what we do in basis path coverage, right? So basis path testing, basically, in some books, basis paths are also is a name for the linearly independent path. So they use it interchangeably, but here, as like ma'am taught, like basis path testing is the testing name, and the test criteria, right? Not test criteria. The test requirement will be given by the number of or the uh, linear linearly independent paths, right? And number of the number of linear independent path we can create in a CFG, that you can get it by the cyclomatic complexity. So does it make sense? Do I have to show another example with little complex something? Do you want me to show?
Sir, something a bit more complex would be appreciated.
No, my first question is like, uh, the concept is clear, right? I can go
Yes,
for
sir.
a complex graph. Anand, is it clear, right? Does it make sense what I'm saying?
Yeah. So there is one more aspect, sir. I want to know.
Yeah.
Can you scroll down? There is a slide that talks about subsumption. Uh, can you? I think it's still down. I think 2 3 slides below. Mm, no, there is one more slide. Yeah. So
It
it
subsumes
says
branch.
basis path subsumes branch coverage. Can you elaborate on this? There is also a practice question, I think, on this, if I'm not
It's
wrong.
true, right? Because uh,
So
if you
what exactly do we mean by branch coverage? Is it
branch coverage is very similar to the age coverage thing, actually. Like, it's basically a traditional testing. Branch coverage is a traditional testing. We haven't covered it in 1 2 week, right? So it basically checks out, do you have test case for testing each branch of your like CFG. So um, if you look at that, here I'm having a branching, so I should have a path, test path, which will cover this and this, both the branches, right? So it's similar to, you can say it's similar to the age coverage. So um, suppose I give a criteria, like I have 1 2 3, say 4, right? So if you go for a node coverage, then your sufficient thing will be like 1 3 2 4, right? It covers up every node,
yeah.
but it doesn't cover all the branches, right? Here the branching is happening, which says that you have to cover this as well as this. So it's similar to edge coverage, that's all. Now prime paths are decided in a way that it will cover both the things, right? All the branches. So that's why it is subsumed. So If you want to go for reading in a details, there is a book by Rajiv Mal. So Rajiv Mal is a professor. He's a professor in IIT Kharagpur. So he's having a software engineering book. So I don't know that soft copy is available or not.
Yes, sir, it is available. The book is called
Then you can just check
Fundamentals.
out. It's he has discussed this traditional testing. So here we are not using the traditional testing techniques. So we are using the new techniques. So we have just touched it. But there he has like discussed that statement coverage, the node coverage. What we say here, no. So
Yeah.
a traditional testing calls it's a statement coverage. So each statement is maybe one node, right? So if I go 1, 3, 2, 4, I can say all the statements are covered. But that's not a good coverage because we are missing this particular path. So branch testing is a kind of branch coverage is a kind of a edge coverage kind of thing, right? So it's defined in a different way by definition, but actually the coverage you'll get same for node coverage and statement coverage, whereas the edge coverage gives the similar coverage of a branch coverage. But this linearly independent path, so that algorithm itself is a difficult algorithm to implement because you want to like this is a simple thing, so manually I can easily find out. But whenever you're writing a program that from 1 you have to reach 6, so you'll be having a lot of combinations of the things, right? So that's why that you have to put a maximum limit, like that's the cyclomatic complexity, how many time I'll do the search in max. So that kind of criteria. So that's the thing. So the prime path coverage basically guarantees that it will look for all the branches. That's all. So now I need to explain that. Okay, I'll just check out which slide I have a bigger graph so that it becomes easier. Maybe that we have done one thing in week 3, I think, that prime path coverage. It was a big graph. Yeah, I got it. Let me share it. So this basis path testing basically give a very good coverage, but problem is like finding out the linearly independent path is a difficult or complicated algorithm. It's time complexity is very high. So if you look at this graph, can you tell me what is the cyclomatic complexity of this graph? So as per the formula, if you go, I have to check out. It's e minus n plus 2. So what is no n minus e or e minus n? N minus e,
E
right?
minus A minus
Yeah.
N is 2.
N minus e. Yeah, n minus e.
No, sir, it's A minus N only.
E minus n. Uh, yes. Okay. So 1, 2, 3. Okay, so I am having 8 nodes. Number of edges 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 2. So it's going to be 3. But easier one is find out how many decision making things are there. So here you are making decision, right? Here you are making decision. So 2 plus 1. So it's 3, right? So there are 3. So you're supposed to get 3 linearly independent path over here. So one, I can definitely see this. This is the easiest one. So I think it's intuitive also. So one will be like, so it's basically cover all, but yeah, we can have uh, one like this and we can have one like this. Right? This is the maximum number of independent, linearly independent path I can have, because cyclomatic gives the complexity, give the maximum number of linear independent paths are possible. So, so these many paths if we cover, basically we're going to test each branches, each nodes, etc. Right? Yeah, somebody was telling something, right?
Yeah, actually, we can also can take the path of 1, 2, 3, 5, 6, 7, and 8. That cannot be the independent part as well.
Which one?
1, 2, 3, 5, 6, 7, and 8. 7, 6, and 8.
I took that also, no? 1, 2, 3, 5, 6,
And
8.
6, 8.
Yeah, I took it, right? Maybe it's not visible. I'll just draw in a different color. So this is another. So this is the maximum number of independent path I can have. So it guarantees that it will cover all the branches, all the nodes. Okay. So one more thing, you have to be little careful here whenever the formula is there. So the main formula having a p component also. I don't know it's there or not here. Yeah, p.
Yeah, it is there. There's a
Yeah,
P.
yeah. So what is p?
Connected components.
So what is that?
Loops.
Basically, if graph are connected in a multiple ways, like one graph is there and there is a second graph and third graph, then we
Uh,
can also find the cyclomatic complexity within that.
can you repeat? I didn't get it.
Uh, like there, we can find strongly connected components in the DFS. Like that, we can
Uh,
also using that we can find the connected components, number of connected components using that and
uh,
cyclomatic complexity.
okay. So anybody else? Any comments on that?
Uh, from what I understand is, so if every node can be reached from every other node through a
Hmm.
forward or backward edge, then it is one single connected component.
Yeah, that's correct. So like that, I can have multiple components, and I need to take care of that also. So, okay, next was this DD path. DD path itself is a confusing thing. Confusing in the sense it's simple, but how it is formulated, I don't know why it is formulated like this. But the thing is, like DD path supposed to be any path between two decisions by definition. So any path between two decision, it could be one node, a path with a one node, it could be path with a two node or more nodes, right? So two decisions means, uh, if I go this graph, so decision taking happening eventually into these two nodes, right? So it's saying any path between them. So I can assume a path 1, 2, 3. I can take a path 1, I can take a path 2, I can take also a path 3. Again, I can take a path 1, 5, sorry, 3, 5. I can take it as a 3, I can take it also as a 5 because it's a any path. But I cannot have 6, 7 because then I'll go, or I'll basically touch another decision, right? So that I cannot do. The point is, so I can go 3, 4, but I cannot come back to 3 because in that case I'll reach another decision. So the way every node is a decision path, right? So it says first that any node with, it's trying, first definition is trying to cover all the nodes. right? So it say any node having just one incoming, sorry, zero incoming node. So zero incoming node means definitely it is the uh, initial node. It's say zero outgoing node. So it's definitely the final node. It's say any node where you are having one, two outgoing vertex, two outgoing edges, or two incoming edges. So he's considering these are as a decision nodes. So this is two outgoing edges. This is two outgoing edges, right? So these are also included. Then it says that any node with one incoming and one outgoing. So that is also a decision. But it's like that, it covers all the nodes. So if you create the test cases which will cover eventually all the nodes in this way, that's basically covered the DD path criteria. But here the important thing is there is a max chain criteria also. So max chain criteria having a different kind of thing. So which basically reduce our test requirement. So what is that? Oh, sorry, rather than deleting it, let me delete only this part. That will be fine. Yeah. So if you look at the decisions, this thing. First, let me check out. So it consists of a single vertex with in degree 0, out degree 0. So that's the first in initial and the final vertex. And then it consists of single vertex with in degree, out degree. It's a simple node, right? In between somewhere. And in degree and out degree, two decision vertices. So these are all included. So this covers eventually all the vertices inside your graph. But the important point is it could also have a max chain. So that basically given because it will reduce your test requirements. So what is that? So a chain is something like the initial and terminal vertices should be different, and interior node should have one in degree and one out degree, right? So if you look at this, right? So you can say this 3 4, it creates a max chain. So it start with a node and end with a node, those are distinct. And within this, what are the vertices we have? Let's have a in degree 1 and out degree 1. So that will do what? In between two decisions, whatever the nodes will lie. So these are basically in a sequential execution, right? Because it is saying in degree 1 and out degree 1. So there is no branching, right? So if I have even a path, suppose I have a 1, then I have a 2, I have a 3, I have a 4, then I am having a 5, right? And here maybe I am having a 6, I am directly reaching over here. So now eventually testing all together and testing them separately will have a same effect, right? So max chain basically covered of a chain which is of maximum size. So it will be basically presenting a single node between two decision node. So that's the max chain concept is. So it either will take care of every node, but it can create or reduce the decision by considering the maximum chain, so that what it will do between two decision nodes, it treat all the nodes which are having one incoming one outgoing as a single node. So that's how for this graph it considered this 3 and 4 as a single testing thing. These are together, right? But these things do not have much effect now because we are having the test cases which are more like test coverage criteria which are more powerful than this. But these are basically for some kind of completeness to have inside the course. But definitely our prime path kind of criteria is more powerful than what we have discussed over here. But again, I'll repeat, this linearly independent path is very nice thing actually to have, because it gives very less number of test criteria, and possibly the minimum number of test cases also. But the problem is, algorithm, we do not have a very nice algorithm still now to find out all the linearly independent paths. That's the problem, right? Yeah, so that last part I have covered. One more question was there, no? Somebody asked one more question.
So
I'm missing
practice
that.
assignment 4, question number 5.
Okay. So Afnan, you have joined, right? Is it possible for you to share it? Hello? Do you have it open with you right now?
Yes, sir. Just a second.
Yeah, can you share it?
Yes, sir, just a second.
Yeah.
So this is the question.
Yeah, I'm reading it.
Yes, sir.
Give me a minute. I'll try to fetch the slide. Huh?
Yes, sir.
Can I try to answer this one? I mean, from what I know.
Yeah, yeah, Anand, please. I'll by the time I'll fetch it.
Yeah. So from what I understand, is that the first two options are the subsets of the test cases that can come that are required, right? So we don't need to just look for the violations, or we don't need to just look for those who satisfy. We need to look for all the sequences of method calls. That is what I understand. That's the way I answered it.
I got confused because in the lecture, ma'am says after the definition of sequencing constraints with the graph, she says that we always look for ways to violate the requirements because sequencing constraints are often not written down formally. So testers always look for violating conditions for the test methods. So that is why I got confused in it. That she's saying that we use it for testing violations, but I mean, yeah,
Uh, does it talk about, are you talking about this particular context, sequencing constraint
yeah,
condition?
yeah.
Okay. Which, okay, let me go through that.
Excuse me, may I add something here?
Please,
Oh yeah,
Yes.
so this is regarding question number 5, I see, right? So
yeah.
it says, to test sequencing constraints that occur as requirement specification, which of the following tests are used, right? So herein it says, a note that it says the tests are imposed to sequencing constraints that violate them. Right, because as Professor mentioned in the lecture, right, as you mentioned that she mentioned in the lecture too, that we look for inputs so that those inputs are actually violating the constraint. That is because, of course, first of the reason is that those constraints are not formally written as such, so it might be possible that while developing or while coding a particular module, we might have missed it, right? So certain checks are not in place, and therefore these constraints are not being adhered to by the program, and therefore we look for that. Because if you don't try to look to violate them as a tester, right, then you might not be able to realize it. Like for
Right,
example,
right,
right, like for example, the developer, he is developing for functional correctness. Let's say he or she is developing for functional correctness of a particular module. So that particular module, he's also looking into it. Like unit testing is there too. So I mean, like whilst you're writing the code, you're writing it. So maybe the objective of that particular module is being achieved. That's okay. But sequencing constraints are something, additional in some sense, right? So
right.
if you don't pay attention to that, you might miss it out. So what happens as a tester also, if I only check for functional correctness, give inputs such that those functional correctness requirements are satisfied, and that is fine. But I might not be able to realize that there exists a violation of the constraints also until unless I give inputs such that they kind of force the program to go into that kind of state. I hope you're right, getting what I'm trying to
Yeah,
say,
yeah,
right? And that is why it is the case. It is similar to what happens in the, as a tester, see, I mean, like, put it simply, as a tester, our job is to break the program as much as possible, right? So here the same analogy applies. We also try to, make the program, force the program go into certain states which are not valid, as in those which are violating the constraints, so that we can inform the developer or whatever the development team is, that they can fix their implementation so that these constraints are, taken care of.
right.
Well, yeah, exactly, and that is why we look for inputs which are actually violating them and not satisfying, because satisfying is the default behavior, right?
Yep,
You'll
yep.
always satisfy until unless you if you don't have it. Like let's say for example, I mean, if something does not exist, then basically you take it as true, in some sense. So
Yeah,
yeah, so I mean, like if the constraints are not there, it is, in other words, we mean to say that those are basically satisfied, because
yep.
our default assumption is to assume that
That it's
yeah,
working as intended. Yep.
yes, exactly, and therefore our perspective as a tester changes slightly, and we look for something which actually violates them so that we can make a case in point in some sense.
Right.
uh, yeah, that is it. Yeah, hope that's clear.
Yeah, the main problem is the answer key says that it's this option which is correct.
Test the sequences of method call, is it? Okay.
Yeah, I mean the definition is obviously correct,
Hmm.
but
Yes, it is indeed the sequences of method calls. But within that also, I think there is slight ambiguity, right? Yeah. I get that. So I mean, this last thing is actually, in fact, the first option is in addition to what the last option is. So tests are
yeah, what
sequences of
Anand was saying, it's a subset. Yeah,
yes, exactly. So tests are sequences of method calls, and it is such that it is also possibly violating the constraint, so that we can figure that out, right?
right.
So it should be both, or in some sense, we'll have to rephrase it so as to avoid that ambiguity that is arising. Okay,
Right.
thank you so much. It is noted. We'll take care of that.
Yeah, right. Thank you. That was all.
Also, I want to add that why not option B, because option B is also the part of the test sequences of method call. Because for true cases, like even for a loop, after 10 loop, is it giving the right answer?
Okay, yeah, I get your point, Abhinit. So I mean, like that accounts, basically, the other test cases basically account for that, right? Because let's say constraints are somewhat like preconditions, right? So if the constraints or the sequencing constraints are not satisfied, then it is unlikely that you'll get to your whatever output you desire, right? So I mean, like this is like precondition. So you satisfy that first, and then only you go into whatever functional objective you want to get out of your method. So basically, those test cases which are actually satisfying the constraints are the default ones, as I mentioned earlier also. Like, so the other, it is not all, like it is not like, sequencing constraints are one of the things that we test, right? So there are other test cases which are not taking that into account. So when you add this to your test set, like test cases which are testing for the sequencing constraints also, then that becomes specific to those cases wherein it is not satisfied, that is, wherein it is violated. So we'll take care of that, and the rest of them, whatever is left out of the test cases, is actually testing for those cases which are actually satisfying that. So I mean, there is no need to explicitly check that in that sense. uh, uh, does that make sense? Abhini?
Yeah.
Okay. Okay. All right. Any other questions that you might have? I think there was this query on discourse. I think Anand posted it regarding the procedure call interface and the client server. May I know what was the doubt there, if possible?
Uh, yeah, Afnan. Yeah, so I thought, I mean, since that came first in the list of options, I was actually looking at whether it could be right.
Mm-hmm.
And I thought it could be, if there was, we were considering a hypothetical situation of having one client and a server,
Mm-hmm.
right? So actually, it is just like a procedure call, right, between the client and the server. They are pretty much the same.
You're talking about remote procedure call, I think, interface, RPC, right?
Yeah, right, right.
I see. Okay, okay. I think we might not have phrased it in that context. So herein, when we talk of client server, we generally okay. Yeah, I understand that there might be an assumption going on behind the scenes, but apparently the client server that we are talking of here are basically decoupled systems. So let's say HTTP and all that. Therein, of
Oh,
course,
okay.
you can see that control cannot be passed. So, for example, I request google.com, it opens for me the website, but of course, my influence is not on the control. I can only uh, send the input basically, right? The behavior is not influenced by what I sent. I mean, it is influenced, but I cannot directly control affect the control flow in some sense. I mean, it might not be a good example, but that is what. So, wherein in the procedure call thing, basically what you do is that you're also trying to influence the control also. I mean, like you can pass in some sense the
Right,
control
right,
control information also, and thereby affect the execution flow of the program, or for that matter the other, whatever is there on the other hand. So for example, it might be a module or another library or anything of that kind. So of course, I mean, like the procedure call in some sense encapsulates remote procedure calls also. It is not that when we say procedure call, it is meant to be within the same program. It can also be remote procedure call, and thereby also might be happening over a network. So in that sense, it also becomes client server. But in the
okay,
strict sense, in the strict sense, the client server here means the decoupled system, right? As in the web and so
okay,
on.
okay, okay.
Yeah.
Understood.
All right. Is there anything else that you would like to
No,
uh,
I don't have anything to
Okay,
discuss
okay. I
specifically.
just wanted to, I just wanted you to discuss a little bit about the DD paths and
I have discussed that.
yeah, yeah. Thank you so much for that, because I myself was not like very much clear about the definition, so I thought it will be better if you could cover that too, and so that's why I think
Do
that
you
is all.
have a plan to do anything today?
Nothing specific, sir. So there was this request in the earlier live session. In fact, we are very sorry. We will not. We are not. We will. We were not able to conduct one open session. So there was this request of conducting an open session, specifically for J unit. I think Bhavya requested.
Yeah, yeah, I had asked for it in one of the sessions.
Exactly, exactly. And it so happened that we in fact requested for it to be scheduled, but for some operational reason, I believe it was, I mean, like it was not scheduled, and therefore it was not conducted. We will try our best to maybe do this before the next live session happens. Of course,
Yeah,
for
all right.
hmm. Yeah, please go ahead, Bhavya.
No, I was just saying that before it would be appreciated if it could be arranged. That was all I was saying.
Yeah, yeah, definitely. Okay, yeah, we'll try for that. In fact, we had requested it from our side, but I think there were operational constraints due to which it could not be conducted back then. Apparently, should be.
Maybe
Mm,
on Saturday morning we can do it, right?
yeah, yeah.
Okay,
Okay,
okay.
what time will be like the best suited time for you all to join in, especially those who wish to discuss that in particular, because then I will be able to,
Saturday, if you want to do it, like I have to do it on a daytime only. Evening, I'm having other classes. So daytime, I think you're free. Okay, 12 is
12.
fine. Yeah,
Yeah,
it
12 is fine. We can, yeah.
11 to 12 also fine. Yeah, we'll check out with ops team what
Yeah,
are the
okay.
schedule and all.
Yeah,
We'll
depending
do
on
it.
the slots, we'll do that. Yeah. Yeah. Thank you.
Okay, I'll stop streaming then.
Yes, sir. I think we can do that. Thank you all for joining.
Sure. Bye.
Thanks.